Hey everybody, welcome to another episode of Steam at the Library. I'm Cody from the Okanagan Regional Library, and today we're going to be folding paper in thirds. Now, folding things into thirds is not necessarily the easiest thing to eyeball. You can't just fold something into thirds with... What does that work? So normally when you fold stuff into thirds, it doesn't work super great like that. You're going to find that, well, you're going to have a little bit of a gap or a little bit of an overhang, unless you find some way of making it a little bit more precise for yourself. Now, there's two ways to do it. One, you probably already figured it out. Just use a ruler. That's obvious. Yeah. I mean, I'll go through it, but the really interesting construction we're going to go through today is going to be how we do it without a ruler, just using folds in the paper and a straight edge. So let's get started. So let's look at some ways we could do it. Starting with the obvious. We take a ruler, or in my case, a mat that has a ruler printed on it, measure our sheet of paper, do a little bit of math, and we find 1/3 the length of the piece of paper. In our case here, this was 11 inches, so 1/3 of 11 is going to be 3 2/3 inches. We just locate 3 2/3 on our measuring thing. Now, my ruler didn't have 2/3 divisions, so I had to approximate. And we fold. And we get a pretty good result. I don't think anybody's going to be complaining about that. Alright, so that was pretty easy. All you got to do is divide by 3. It doesn't take a whole lot to get the math done in that case. So what are we going to do if we don't have a ruler? Or maybe we just have no idea how long our sheet of paper is, so it's hard to even eyeball it. After all, it's kind of hard to mentally divide something into thirds. That's why folding into thirds in the first place without a ruler is so hard. So how are we going to do it? Let's have a look. So you're going to start by folding the sheet in half the wrong way. That is, the wide length of the sheet rather than the narrow length of a sheet. We fold it in half, and fold it in half again to get quarters. These aren't going to be our final folds, but they are going to be landmarks for us to find stuff later on. Now here comes the tricky part. We're going to need a straight edge for this one. Now I have this conveniently blank mat with no ruler markings on it. So what we're going to do is we're going to count down 3/4 of the way down the sheet. And we're going to draw a line from that to the opposite corner. Good practice when using a straight edge is to use a very, very sharp pencil. I might have blown a few takes trying to get away without sharpening my pencil. Sharpen your pencils, people. Once we get a line going from the top corner to 3/4 of the way down on the opposite side, we find that we have a very, very interesting property. We have 3 segments of equal width, so 1/3 of that line is going to be in each of those segments. And by extension, 1/3 of the sheet of paper is going to be where that line crosses the folded paper. So we make our marks. With only one point here, it is tricky. I find the best way is to make sure my one edge is completely parallel, lines up exactly with the other side of the paper. And we fold. And fold again. And voila! One paper folded into thirds without a ruler. Now this technique is very, very sensitive to small errors that you might make in drawing your line or folding, so be very, very precise when you're doing this. So that worked pretty good, didn't it? I mean, the piece of paper is very creased and it has lines on it, but we have a very, very precise fold without using a ruler at all. Very handy. So, I mean, how are we going to use that for actually folding a letter? Well, you could use it as a guide. Do the folds that we use today in a sacrificial piece of paper, and use that to kind of decide where you're going to put the folds into the actual letter that you want to send. It would save a whole lot of strife, if you didn't have a ruler at least. But how does a technique work? I mean, why does it work? Well, let's have a look at it. Well, let's start by giving things names. We'll call the length of 1/4 of the short edge of the page A. We'll call the length of a long edge of the page B. So we can see that we're forming a triangle here with the bottom side being of length B and the vertical side being of length 3A. So we're going to throw this into our good old trusty Pythagorean formula. The length of the hypotenuse is the square root of the sum of the squares. Now we divide through by 3, moving the 1/3 into the square root. You can see it cancels out with the square on the 3A and it goes inside the square of the B. So now let's look back at our graph. We're going to focus on these smaller triangles. Now we know the length of the hypotenuse is going to be L over 3, since we are dividing this into thirds. We know the length of the vertical side is going to be A. Once again, we plug and chug through our friend Pythagoras, and we get our result, B over 3, which is 1/3 the length of the sheet of paper. Convenient, right? This also makes some intuitive sense. We're dividing that line into 3 segments. Each of those segments are effectively identical. So the horizontal component of a line, or the projection of that line onto the horizontal axis, that's also going to be cut into thirds. Hey guys, thanks for sticking with it today. I really appreciate it. Now, subscribe to the channel if you want to see more STEAM content like this, and if you guys have a good time folding pieces of paper, then I have done my job today. So give it a go and enjoy.